Hi guys, I hope you are fine. Me too, I'm fine. So, we thank God for this opportunity to learn together. So, guys, let me just do these questions. You might have seen them earlier, but I decided to do some kind of revision because of one or two omissions. And so, guys, this is now how it should be done. So, the first one is, or I read the question, it says, evaluate the following integrals. We have Roman 1 and we have Roman 2. So I've decided to start with Roman 2. For this one, we use what we call integration by parts. And here is our equation for integration of by parts. So what we do, guys, is that we come and use this equation whereby we have the u. The u is represented by this. That is e raised to x. And then the dv is supposed to be represented by all this. That is dv is equals to cos x dx. From there, guys, we come and integrate, differentiate the du. When we differentiate the du, it will still remain the same, e raised to x. Here we say du dx, but instead of putting dx in this side, we put here. So we'll have du is equals to e raised to x dx. We come now and integrate that. When you integrate that, you get v is equals to sin x. Because remember, guys, if I were to differentiate sin x, I would get cos x. It would be dv all over dx, but now dx I put there, and then this one would change to cos x, just like it is here. So guys, that is how we do that. So from there, guys, I come and replace in my equation here. This I have repeated just as I had written here. This is our ex represented by u, then the dv represent this. So this one will be equals to u. Now you go to where u is e raised to x. That one. V is sin x, so I put it here, minus integral of v. V is sin x, and then du is e raised to x dx. From there, guys, we come and now integrate this, because after replacing v and du, we find that we will still have to integrate again. So I have chosen my u to be ex, so the remaining, that is sin x dx, will be my dv. So now I come and integrate that is sin x dx. dv over dx is equals to sin x. I integrate, you get that. And every time you integrate, guys, you can always try to differentiate and see whether you get your original value. That is I differentiate the v, that is dv dx. I find whether you are going to find sin x. For ours, you'll find the same answer. So that's okay. Now we come to u. For the u now is ex. You can differentiate that one. It still remains the same, guys. And so, guys, now we come and replace. This is the originally the way it was. Then we found that, and then we come to this position. For this position is actually integral of sin x and then e raised to x dx. So instead of repeating this one, we went ahead and wrote now the u and v, whereby the u is going to be e raised to x and the v is going to be minus cos x, which is here. So we are not repeating again this we are not repeating again. We are just going direct to now uv minus integral of v du. This is the uv minus the integral of v, which is minus cos x, and then the u is e raised to x dx, like that, guys. And then from there, guys, even before we come to say let the integral e raised to x cos x dx is equals to I, we come and evaluate this. When we evaluate, we'll get this. We'll get e raised to x sin x minus, because here we have another minus, then this one becomes a plus. Then these two minuses will become plus, but now they shall be changed by this negative, so that now we shall have a negative. Because remember, negative and negative become plus, but now there is still another one here, which now makes it negative. Now this value we get here, guys, as you can see, is actually the same as our question. Our question here, that is integral of ex cos x dx is the same. And that's why now, guys, I have come and said, let integral e raised to x cos x dx be equals to I. So that's what I have done, guys. And so that now, guys, we have I, which is now our question, is equals to that, and then minus I, because this is similar to the question. Now you can put your I on this other side. It was negative formerly, but now it becomes I. So I plus I gives us 2I. And finally, we can now divide by 2 this side and divide by 2 this side. So that now, guys, we are left with this. So that the question now, which is the integral that was given, or what we were supposed to solve, is now equal to that. And that's what I have written here, guys. And so this is now our solution, guys. And this is our question and our solution here. So, guys, this is what we now get as our solution. So let's go to the next one, guys. Here it is. For this other one, guys, ln x, we say it is u. And that's why I have rearranged it here, so that now we can separate ln x from the rest. The rest is x cubed dx. X cubed dx is what we consider as dv. Ln x is what we consider as u. And then we come and differentiate ln x, we get that. We integrate x cubed, we get that. After that, guys, now we come and replace in our equation. That is, we have the equation of partial fraction, whereby this is the question. Then we have here u and v. Our u is supposed to be ln x. Our v is x raised to 4 over 4 minus integral of now du v du. V is x raised to 4 power 4 all over 4. And our du is 1 over x dx. Because of that now, guys, we can cancel one of the x here. We remain with 3 x's. That is x raised to 3. So from there, guys, we can actually be able now to integrate this integral. Because now that integral will now be x raised to 4 all over 16. Then it means now we have been able to solve the question, because already we had our first integral. From our first integral we got this. This is the uv. And now we now integrate this. So finally we get this x raised to this one, which is that. I've just rearranged it, but still the same. Then minus x raised to that is raised to 4 all over 16 now, plus a constant. That, guys, reminds me that even what we had done here, since it was an indefinite integral, would have to add a constant here. So that one was forgotten, but now I've just remembered, even as we do our question here. So this one was supposed to have a constant. And so, guys, that is how we do integration by parts. So guys, thank you so much for listening to me. Bye bye.